Hello everyone, you are welcome to another video session of Python for All. I'm your regular host, Dr. Michael Ekwono. In this video, we will continue and conclude our discussion on Python data structure with another special data structure, which is known as ByteArray. ByteArray class is a mutable sequence of integers in the range of 0 and 256. In other words, greater than or equal to 0 and less than or equal to 256. It is similar to bytes, but it can be modified. This makes it useful for working with binary data such as images, audio, and files. The byte array function can be used to create a new byte array object. The syntax is byte array of initializer and encoding in parentheses. For example, the following code creates a byte array object with the letters hello world in it. Let's run this cell. Here we have a byte array function of hello world, which is encoded with UTF-8. If I run this cell, it gives me a byte array of hello world. The B before the hello world tells us that this has been converted into a byte array. Byte array objects can be modified by using the following methods, as in the case of list and other data structure. Here we can append. In other words, we can add a byte or a sequence of bytes to the end of the byte array object. We can extend by adding a sequence of bytes to the end of the byte array object. We can insert by uh, putting a byte or a sequence of bytes into the byte array object at a specific index. We can remove, in other words, we can remove a byte or a sequence of bytes from the byte array object at a specified index. We can pop, in this case, we remove and return the last byte from the byte array object. And lastly, but not the least, we can clear. Here we can remove all the bytes from the byte array object. There are other methods that can be used to manipulate the byte array. If you want to know those methods, simply call help on byte array in either the Python interpreter, the Tony shell, or the Spider IPython console, and it gives you a detailed description of those methods. The byte array can be converted into bytes by using the bytes function. I hope I wish to mention here that both the byte array function and the bytes function are built-in functions in Python. The byte functions will create a new byte object with the same elements as the byte array object. Here we'll look at an example in this cell where we call bytes function on byte array of hello world with UTF-8 encoding. If we run this cell, it returns the byte of hello world. In other words, we have converted the byte array into a byte of hello world, and it begins with a B. Next, I want to demonstrate or also take an example by reading an image. In this case, I want to read the logo of this course, which is PY4A. As shown here, this image is saved in a folder, in a subfolder rather, in messed up mentors known as thumbnails. In other words, I have a root folder, messed up mentors, and I have subfolders right inside there, one of which is notes, another video, another photos, another thumbnails, and so on and so forth. So all I need to do to read this image is to use the pill library or the pillow library. So I say here from pillow import image. You can likewise say import pill and then you call image by saying pill.image. But I prefer to keep my namespace unclustered. So I import the specific module I want to use in pillow. So that's why you see the import statement from pillow import image. And then I would simply assign, the image with small letter img equals image dot open, and you can see here I put in the part of the image I want to open. I've used two double dots here as a relative referencing to exit the current working directory where this Jupyter notebook is saved, which is in notes. So with double dot, it takes me out of that working directory, and then I slash move straight into thumbnails and then the image name. So if I run this cell and then you see the image has been opened, if I print image, it references, gives me a string of, you know, the image encoded with in PIL format. So it tells me here the image mode is RGBA, red, green, blue, alpha. So it is four dimensional. The size is 300 by 160, the width by the height at the location which the image is being stored, the storage location of the image that has been loaded. Next, I can print the size of the image to confirm. You see, it prints the size 300 by 160. Here, Peel reads its image format in width by height. We will see all this when we get to image manipulation and computer vision in our subsequent videos in this course. Next, I want to convert this image to an array so that I can read every pixel value in that image. So to do that, I need another library known as NumPy. So here I've imported NumPy as an alias np. We can do that. So we can say import NumPy as, import SciPy as, import this package as, and then you take an abbreviation of it. So here I have import NumPy as np. You will see this often in most Python codes. Some people prefer to use import numpy. It's okay, but I prefer to use the alias, the short form, import numpy as np. Then I can now call np of any module that I need in the numpy package. So here I want to convert this image img to array. So I have image array, and I first of all run this cell, import numpy. I have my library imported. You have to run it. If it's not run, your library is not in your namespace. So next I would call np.asArray. That's one way of converting to array. You can also call np.array. It also converts it to an array. Of what? Of the image. If I run it, I already have my image array in my namespace. And next, let me print my image array. If you print, you see it gives us a four-dimensional array. We will talk more about array matrices and its dimension when we get to NumPy and vectorization in our subsequent videos in this course. So having, you see, is a long list, and can also, as you can see from here, at some point you'll see three dots, which means that those values have been condensed. It's quite large. It's about 192,000 elements values. So now another thing I can do here is, now that I have the image array, I can find the shape of the array and it tells me the exact dimension of the array. And then I can find the size, which tells me the total number of elements or bytes in that array. If I run this cell likewise, it gives you a 160 by 300 by 4. You can see here NumPy reads its image in the format height by width, which is 160 by the height, 300 of the width, uh, in four depths or four layers. That's what we'll talk about dimension. We'll see all of this shortly. So next, if I print the image array dot size, it gives me 192,000. That's the total number of pixels in that image, 160 by 300 by 4. So as the image gets larger, the number of pixels get larger, it also consumes memory. You see here, when we get to image analysis and image handling, I would show you a technique that you can use to, minimize memory consumption of your code when loading images on, or when reading and writing images. So lastly here, I want to now print out the pixel value so you can have an idea of the range of those pixel values. Like we have said earlier, that the byte array is simply a sequence of numbers between 0 and 255, beginning from 0 and ending at 255. The last value is 6. Is a range of values. So there I do for px in image array print asterisk ps. I also explain this shortly when we talk about functions, and then we see what that single asterisk mean and double. Actually, we will discuss that under unpacking of list, tuple unpacking, list unpacking, and all of that very shortly. So if I run this cell, you see what is being printed out: a whole list of 192,000 elements or bytes. So with zero, 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 zeros, and where we have other, we see other values: 40, 170, 244, 43, 167, 242, 119, and where we don't have, where we have dark regions or black points, they are all zeros, and white point 255. I will not want to talk more about this until we get to image handling, image manipulation, and computer vision. So this is just the byte. You can see none of these byte exceeds this value of 255 or 256, so zero, very long list of it. So this is just exactly what is inside this condensed array that we printed earlier, and all of these values is a representation of this image py4a. With this, we have come to the end of this video, which I intend to be very short and brief so that my audience can easily digest its content. If you have any question, please leave it in the comment section. Like this video, share this video, and if you are watching this video and you have not subscribed to my channel, please subscribe to this channel to get exclusive content. Also, click the notification bell to get notified whenever I have new videos uploaded. Until then, see you in my next video. Bye.